NASA has revealed an astonishing finding about 3I Atlas, an interstellar object speeding through our solar system at over 153,000 miles per hour. As it exits, the object is spewing pristine ice water, methane, carbon dioxide, and methanol materials that have remained untouched for billions of years. This unexpected outburst, captured by NASA's SPHEREx and other infrared telescopes, shows that 3I Atlas continues to release these volatile compounds long after it passed its closest approach to the Sun. Unlike typical comets that go dormant once they move away from the Sun, 3I Atlas defies all predictions, revealing a deep, ancient chemical storehouse. These ices, which have been preserved since the comet's formation in a distant star system, offer a rare glimpse into the early stages of planetary and possibly life-forming chemistry, providing scientists with an invaluable opportunity to study interstellar materials that have remained virtually unchanged for eons. As 3I Atlas exits the solar system, its unexpected activity raises more questions than it answers. After its perihelion, where it came closest to the Sun, the object's light did not dim as anticipated. Instead, the comet experienced a dramatic flare-up, a burst of brightness that continued far beyond the typical range for such celestial bodies. This outburst, caused by the sublimation of deep interior ices, released a cocktail of gases including water vapor, carbon dioxide, methane, and methanol, some of the very elements needed for life. These gases, described as pristine, are thought to have been locked in the comet's core for billions of years, untouched by the harsh conditions of space. The presence of these molecules was the first significant clue that 3I Atlas is no ordinary comet. What makes this behavior so extraordinary is that comets in our solar system are typically only active near the Sun, where solar radiation causes the surface ice to sublimate and release gas and dust. As they travel away from the Sun, these objects usually go dormant. Their gas is frozen once more into the cold vacuum of space. But 3I Atlas defies this pattern, suggesting a more complex internal structure. Its continued outgassing challenges the very models that astronomers have relied on for decades. It's as though 3I Atlas is revealing secrets that we were never meant to uncover, volatiles that haven't seen the light of day for an unfathomably long time. NASA's new observations have offered scientists a unique opportunity to study not only the chemical makeup of this object, but also the processes that might have occurred in other star systems. The data gathered from SPHEREx and the Hubble Space Telescope suggest that 3I Atlas carries a chemical record that could provide vital clues about the formation of planets and life across the cosmos. The gases released from 3I Atlas are not simply molecules, they are relics of another stellar system, materials that have remained untouched since their star system formed. These findings could provide a snapshot of what was happening in a distant part of the galaxy when the solar system itself was still in its infancy. In the midst of all the excitement, however, there are still many unknowns. How can 3I Atlas continue to produce gas long after it has passed its closest point to the Sun? Why is its behavior so radically different from that of typical solar system comets? And perhaps most tantalizingly, what if 3I Atlas is not a comet at all? Some have speculated that it could be something else entirely, an artificial object sent by an unknown civilization. While this theory is far from mainstream, its very existence speaks to the depth of the mysteries that 3I Atlas presents. Its behavior is so unusual, so far outside the realm of traditional cometary models, that it has given rise to a wave of alternative hypotheses. One of the most intriguing and perplexing aspects of 3I Atlas's behavior is its unusual jetting pattern, which deviates significantly from the erratic, chaotic outbursts typically seen in comets. Most comets release gas and dust in irregular bursts as they approach the Sun, driven by the sublimation of volatile materials from their surfaces. However, 3I Atlas displays a symmetrical jetting structure. Jets of material are emitted at precise calculated intervals, as though driven by a hidden force. This symmetry is unusual and not easily explained by the natural processes typically observed in comets. According to observations, the jets are positioned 120 degrees apart from one another, a highly ordered configuration that suggests some underlying mechanism far more complex than simple heating and surface sublimation. This highly organized jetting structure raises the question of whether there is something more than just solar radiation driving the outgassing of 3I Atlas. The fact that the jets appear to be emitted at regular intervals suggests that they may be controlled by some internal process within the comet, possibly an internal mechanism that is actively driving these emissions. Could it be that 3I Atlas has an internal engine-like structure that controls the release of material? Such a possibility would be far outside our current understanding of cometary dynamics. If the jets are not simply a result of surface heating, then the object could be undergoing a process that we are not yet able to fully explain. This raises the provocative question: could 3I Atlas be artificial in origin? While this theory is highly speculative and not widely accepted by the scientific community, it has nonetheless captured the imagination of a growing number of researchers. The idea that 3I Atlas might not be a natural object, but something far more sophisticated, possibly even engineered, is gaining traction among those who study the object's anomalous behavior. If true, it would upend our entire understanding of interstellar objects and challenge the distinction between natural and artificial phenomena in space. Beyond the strange and highly ordered jetting behavior, another highly unusual characteristic of 3I Atlas is its trajectory, which seems to defy the gravitational rules that govern most objects within our solar system. Most comets follow highly predictable paths influenced primarily by the gravitational pull of the Sun. However, 3I Atlas's motion through the solar system has raised serious questions about the forces at play in its journey. One of the most startling features of the comet's path is its retrograde motion. It is moving in the opposite direction to most solar system bodies. The fact that 3I Atlas is traveling against the general rotational direction of the solar system adds an unexpected layer of complexity to its trajectory, further raising suspicions that something beyond simple gravitational interactions might be influencing its motion. The path of 3I Atlas is so unusual that it seems almost statistically improbable. The object's trajectory is aligned in such a way that it intersects with the gravitational sphere of influence of Jupiter, the largest planet in our solar system. This type of alignment is rare and highly unlikely given the vast distances between objects in the solar system and the complex gravitational interactions that influence their paths. The fact that 3I Atlas's trajectory intersects with Jupiter's gravity suggests that other forces, perhaps unknown or yet to be understood, might be playing a role in guiding its path through space. As 3I Atlas moves farther from the Sun, its journey through the solar system is far from over, and its path will continue to evolve in ways that could offer critical insights into the nature of interstellar objects. One of the most significant upcoming events in the comet's trajectory will occur on March 16, 2026, when it will make a crucial pass near Jupiter, coming within just 0.238 AU, about 33 million miles of the gas giant. This will mark the closest approach 3I Atlas will make to any planet in our solar system, and it presents an exceptional opportunity for astronomers to study the object under the gravitational influence of one of the most massive bodies in the solar system. Jupiter's immense gravity has a significant effect on the objects that pass close to it. With a mass more than 300 times that of Earth, Jupiter has a powerful gravitational field capable of altering the trajectories of passing comets, asteroids, and other space debris. For 3I Atlas, this flyby will provide a rare chance to observe how an interstellar object interacts with the gravitational forces of a giant planet. As the comet approaches, the gravitational pull of Jupiter could cause small, yet potentially significant shifts in its trajectory, potentially altering its path and speed as it continues its journey out of the solar system. The effects of this encounter could extend beyond just changes to the comet's orbit. The interaction with Jupiter might also influence 3I Atlas's behavior, potentially altering the patterns of outgassing or jetting that scientists have been closely observing. The gravitational forces exerted by Jupiter could cause physical stress on the comet, possibly leading to the release of additional material or even causing structural changes to the object. Scientists will be watching closely for any variations in the comet's brightness, as changes in its activity could offer new clues about its internal structure and composition. This flyby is also an important moment for the broader study of interstellar objects. The comet's passage near Jupiter will provide valuable data on how such objects behave when they encounter the gravitational fields of massive planets, offering a glimpse into the broader dynamics of our solar system and how it interacts with foreign, interstellar visitors. For astronomers, this encounter is a natural experiment in planetary gravity, and it will help inform our understanding of how stellar systems evolve, how objects move through space, and how our solar system's planets influence the trajectories of foreign bodies that pass through. In the years to come, the data collected from this and future encounters will be critical to understanding the full significance of 3I Atlas. If the comet is indeed a remnant of a distant stellar system, it could be one of the last opportunities for scientists to study unmodified materials from outside the solar system. The chemical information locked inside this object could hold the answers to fundamental questions about the formation of solar systems, the spread of life-building molecules, and the behavior of materials in deep space. Its continued journey to the outer reaches of the solar system will offer new opportunities for study and perhaps reveal even more surprises. The significance of 3I Atlas's passage through the solar system extends beyond the scientific community. The object's behavior, its unexpected release of ices, and its possible artificial origin are all factors that have captured the public's imagination. Theories about its origins have sparked widespread speculation, particularly in the context of the WOW signal, the mysterious radio signal detected in 1977 that some believe could have been a message from extraterrestrial intelligence. While the mainstream scientific community remains cautious about jumping to conclusions, the unusual nature of 3I Atlas has made it the subject of both professional and amateur investigations. In the world of space exploration, where the search for life beyond Earth remains one of the foremost goals, 3I Atlas stands as a symbol of both our progress and our limitless curiosity. As we move further into the 21st century, the continued study of objects like 3I Atlas will help to shape our understanding of the cosmos. With the next generation of space telescopes and observation platforms, astronomers hope to detect more interstellar objects passing through our solar system. Each one of these visitors could tell us something new about the building blocks of the universe, the nature of life's spread, and the potential for life beyond our solar system. In the meantime, 3I Atlas remains a mystery, a comet from beyond the stars that continues to defy explanation and inspire wonder. As the comet moves farther into deep space, it will eventually leave our solar system and disappear into the void, its journey continuing far beyond our reach. But for now, it stands as one of the most extraordinary objects ever studied, and its secrets, pristine ice, and all remain tantalizingly just beyond our grasp. For those who have followed its passage, 3I Atlas is more than just a comet. It is a symbol of our unrelenting quest to understand the mysteries of the universe, and a reminder that the answers we seek may be stranger and more awe-inspiring than we can ever imagine.